Good afternoon, people, and welcome back to a new video. Today I thought we would start a series of where I just pretty much do a bunch of mock exams and past papers for GCSEs and A-levels and all that kind of stuff, and so that if you guys need any help, you can just flick through the question it needed. And yeah, so I'll try and explain everything as best as I can, and if you ever have any questions, just let me know in the commentaries. And right, so let's get into it. So this is the paper one for 2023, so it's a non-calculator paper, and I have had a look through, and I'll try and just explain everything in depth, so that if you do happen to come across the question you need, well, you get a pretty good in-depth explanation. Right, so we're going to start off with question 1A as usual. Work out 0.7 times 0.5, so this is pretty simple. There's a couple ways you can do it. You can just simply do, right, what's 7 times 5 is 35, and then you can just calculate 2 decimal places, so which implies that 0.7 times 0.5 is 0.35. So this is possible, or otherwise you can also use fractions. So 7 tenths times 5 tenths gives me 35 out of 100. Which you can translate that to 0.35. Alright, so this is 1A. 1B, so 5/6 divided by 3. So this is a bit easier to think of as 5/6 times 1/3, right? Since divided by 3 is the same as divided by 3/1, and we know that division is the reciprocal of multiplication, so we have this this right here, which gives you in turn 5/18, and yeah, so you can pretty much just leave it like that and you get the right answer, or you can, well, yeah, perfect. So 5/18, I think this is pretty self-explanatory. Now same again, 27 divided by 0.6, so we can go about it a couple ways. The easiest way, I think, is the same way. So we have 27 divided by 0.6 is equal to 27 divided by 6/10, right? Which is in turn, as I just said, 27 times 10/6, right? So which is equal to, we can simplify that right now, which is equal to 27 times 5/3. If you guys are happy, we just divided the top and bottom by 2, and in turn that gives us, so 27 divided by 3 can give you 9 times 5, which gives you easy 45. So right, so this is pretty much it. And yeah, so you can just see here that, like, you can move this to 27 divided by 3 times 5, right? So the third doesn't matter, like multiplication is commutative, so it doesn't really matter which one you do first. Just make sure that you end up dividing by 3 and timesing by 27 and by 5. Right, so now on still pretty easy, question 2. So 2x is smaller than 26, so I think this is pretty simply solved. They just want to see if you can solve something, an easy inequality. So this is divide by 2 on both sides. So you have x is smaller than 13, or 13 is greater than x, whichever you wish, and it goes there. Right, and once again, question 3. Right, so 3/2 squared. So these questions are pretty easy. They're meant to be done in in a few seconds. They're just meant here to test pretty much your knowledge. So 3/2 squared is equal to 3/2 times 3/2, right? So a number squared is a number repeated by itself multiplied. Be careful about that, which gives you in turn, so same again, so 3 times 3 is 9, divided by 4. So you can, and they want the answer as a mixed number, right? So this is equal to, obviously, so 4/4 plus 4/4 plus 1/4, right? And this is 1, this is 1, and this is 1/4. So we have 2 1/4, right? And this is pretty much what we get. Be careful, as all teachers will tell you, read the bloody question, since if you miss it, obviously, and not give it as a mixed number, you get 0 marks here, even if you did get the question right, unfortunately. So you have to be careful, take your time, read the question, read the answer, and then double check it. Right, a bit of angles. ABC, BD, and BE are straight lines. So this is a bit of algebra. So what we can do is, right, so we know the angle EBD is equal to 5 times angle ABE, and angle DBC is equal to 3 times angle ABE. So what we do in this case is pretty simple. We let x equal the angle of EBA, right? So this angle is going to be called x, and then we know that this one is now 5x and this one is 3x, and you want the size of angle EBD, right? So EBD, so you want this one. So how do you do this? Well, you use the fact that angles in the straight line add up to 180 degrees. So you have x plus 5x plus 3x equals 180, which in turn gives you, so 9x equals 180, so you have x equals 180 divided by 9, which is 20 degrees. So you know that this is 20 degrees, so you know that, which implies that angle EBD equals 5 times 20, 100 degrees, right? And awesome, so this is pretty simple. Once again, if you have any questions, just feel free to ask, but I feel like this is pretty simple right now. 2 prime numbers are multiplied together, the answer is an even number between 50 and 60, complete the calculation. Right, so this requires a little bit of thinking. So you know that the answer is an even number, and how do you get an even number in a multiplication? Well, one of the numbers, a times b equals ab, so if ab has to be even, so either a has to be even or b has to be even, one of the two. Because if you'll notice that if you have, for example, 9 times 9 equals 81, so the answer, the result of a multiplication with 2 odd numbers will never give an even number. Right, so we know that we require like an even prime number, and we know that easily that the only even prime number is 2, right? So how does this work? So we know that this is 2, and we know that 2 times something must be between 50 and 60, so we know that 2 times 25 is going to give you 50, 2 times 30 is going to give you 60, so we know that this number must be between 30 and 25. So we can literally go through all the numbers in there and check which ones are primes. So we have 26, which is even, so it's not a prime. We have 27, which is 3 times 9, which is not a prime. We have 28, not a prime either. 29, which is a prime, and 30, which can't be counted. So we know that this is 30, and 2 times 29 is, oh sorry, this is 29, so 2 times 29 is 58, and we are Gucci, right? Good. Right, so next one. So this is question 6. So, right, Andrew and Bruce share some money in the ratio. So a couple of bit of ratios. So Bruce gets £96, and we get a third guy called Carl, which gets some of their money. So pretty much like taxes, eh? So right, so if you have a ratio of 5 to 6, and Bruce gets 96, so we can do it pretty simply, pretty fun. So we know A gets 5x money and B gets 6x money. So we're just respecting the ratios here. And what we can do, we can try and work out what this x does. So if B has 6x, so obviously I didn't say it, but A will be Andrew, B will be Bruce, and C will be Carl. So B has 6x, which is equal to £96. That's in turn going to give us that x is equal to 96 over 6, which is, goodness me, right, what's 96? 10, 15, 16. So £16. So we know that A is going to get 5 times 16 equals £80. We can quickly check that the ratio 80 and 96 is indeed equal to 5 to 6. And now we have how much Carl gets. So we have Carl, pardon me, get a quarter multiplied by what Andrew gets, which is £80, plus 2/3 of what Bruce gets, which is £96, which gives me, so what's a quarter of 80? It's pretty much 20, plus 2/3 of 96, so a third of 96 is going to be 32, times 2 is 64, so we get £84. So Carl gets £84, and we don't care about anything else. Next question. Right, 2a times 3 times 5 squared equals 600. Yeah, work out the value of a. You must show you're working, right? So you could either, so there's multiple ways to go about doing this. I'll just give you one way, and if you guys don't understand it, you can just ask me. But what I'm going to do is just, I'm going to give you the 2a times 5 squared equals 600 divided by 3, which is in turn 200, and then 5 squared, you know that's 25. So you got 2a is equal to 200 divided by 25, which is 8, right? And then you know a equals 3, since 2 times 2 times 2 equals 8, right? Or you can do it, otherwise I'll just do it quickly, 600. You can break that into prime factors, since we all see that those are all prime. So that gives you 2 times 3 gives you 6, times, so we need 100, so 5, so now we need 20. 20 is 4 times 5, which is 2 times 2 times 5, squared times 2 times 2. Right, so I might have made a mistake, but just let me know. But right, 2 times 2, so we have 8, we have 3 in a, right, awesome. So we get 2 cubed times 3 times 5 squared. Right, so this is literally just prime factorization. Right, it's not really difficult at this point. So expand and simplify fully. 5 times 3x plus 4 minus 2 times x minus 1. So this is, once again, just basic knowledge. Obviously, if you guys struggle, just feel free to ask me, right? There are no dumb questions. Right, but like when I say it's basic knowledge, it's what they want to do. But if you don't get it, just feel free to let me know, and I shall do my best to help you guys. So 5 times 3x plus 4. So we'll just go about expanding it. I'll show my working, but you guys in the exam don't have to show all this working. Just be careful that here we have a minus 2 times a minus 1, which is going to do a plus 2. And in this case, we get 15x plus 20 minus 2x plus 2, which gives you 13x plus 22. Right, so I believe this is correct. Well, we'll see, won't we? But, right, so 13x plus 22, next question. Ooh, right, bit different. Erica, interesting name. Erica tries to sketch a graph 1 over x equals y with x not equal to 0, which is good, since you can't divide by 0. Let's see, make 2 criticisms of a sketch. Right, so we can, if you're doing the higher exam or even foundation, you probably have seen this graph before. It's pretty standard, and it goes, it's 2 asymptotes like this, right? So in the negatives, so you divide by a negative number, so obviously it's going to be a negative, and you can't divide by 0. When you have a very small x that's not 0, then 1 divided by that very small number is going to give you quite a large number, as you can see it running off to infinity, and vice versa. When x is very large, 1 over x is going to tend to 0, so this is pretty much how it works. If in the exam you can't remember it, or it's a bit more convoluted, literally just look what happens at 0, look what happens when you tend x to infinity, and minus infinity, and these are basic rules, general rules, but yeah. So, or you can just ask your teacher for some better kind of tactics, right? I'm just trying to do this rather quickly. So x equals, y equals 1 over x. So 2 criticisms. Well, we can see here that she has indeed gotten the value of the graph for x equals 0, which is 1 not defined, and 2 is it's not possible. So this is going to be a first criticism. So for example, y, right, so f of, so let's just say f of 0 equals y equals 1 over 0 is defines but should not be. It's pretty much for a point for saying, right, so she's actually intercepts the graph, or right, so there is y-intercept, right, and there shouldn't be, right. So this is one of the ones, and then the other one is obvious. This one should be on the other side, and pretty much like this. So for the other one, we could just say the top left part of the graph should not have anything, and the graph should instead be on the top, on the bottom left. So top left part of graph should be empty, and bottom left part of graph should have the graph instead. Let's just call it, like, they'll be pretty understanding. I mean, it's kind of obvious at this stage. The graph instead. If you guys look at the mark schemes, I'm sure they'll give you a bunch of explanations or all the points you can say that are a bit better than this one. Yeah, right. So like, I haven't really looked at this question in the mark scheme at all. Yeah, so if you need help, the mark scheme is pretty self-explanatory, I hope. And question 10. Alright, Sunita is X years old, Beth is 1 year younger than Sunita, and Joel is double. Alright, so pretty simple then. So, and they also give you the X, right? So we have S is X years old, so we have Beth, who's X minus 1, and we have Joel that's double Sunita's X, so Joel is going to be 2x, right? And mean of their age is 5, so how do you get the mean? You add x plus x minus 1 plus 2x, divide by the number of people, which is 3, and you know it's 5, so you get 4x minus 1 equals 15, right? It's got 4x is 16, so you have x equals 8. I'm so sorry, x is 4. It's basic maths. And you would like to know how old Joel is, so which implies that Joel is equal to 2x, which equals 8. Right, Joel is 8 years old, 8 years younger. Right. This Venn diagram represents, right, so this is once again basic knowledge to see if you know what these terms mean. So this one means intersect. So when you have the intersect, you just want the so let's ignore the probability right now. So A intersect B are the elements that are in A and in B. So we can, in computer science, they have these AND gates things, which kind of looks like A. So you remember, so it's A and B, and which numbers are in A and B? So it's these 13 here. So obviously, so the probability that we have A and B is 13 out of the total, which is 100 items, so it's 13 out of 100. Work out P, not A. So A dash here is not A. So it's pretty much all the elements that are not in A, as given by the name. So it's going to be these ones and these ones, right? So it's going to be 48 plus 11 out of 100, which is going to be 59 out of 100. Right, and this is it. 59 out of 100. And then PA or B. So this is a bit similar to A intersect B, but this is OR, so or union, as people like to refer it to. So this is pretty much all the numbers that are in A or in B, right? So it's all of them, except the ones that are not. It's that simple. Right, so 28 plus 13 plus 48, which is going to be like 78, 78, 88, 91 minus 2, just going to give you 89. So this could be 89. Actually, let me write it down for you guys so that actually it's clear. 28 plus 13 plus 48 is the equivalent of 50 plus 28 is 78 plus 11. Yep, 89. Simple. Right. A to the n. A times 10 to the n is numbers in standard form, completely inequality. Right, but they don't. Right. Okay. Once again, basic knowledge. They just want to make sure that you know what standard form is. So standard form is when you have a number in this form, literally, but a has got to be between 1 and 10, right? So this is 1 and 10. If you have, for example, 11 times 10 to the n, right? This is gonna be correct, but it's not gonna be in standard form. Not standard form, because you can write that as 1.1 times 10 to the n plus 1, right? Where n is positive. Oh, actually, yeah, no, it doesn't matter. Yeah, so this is literally it. So it's between 1 and 10. Pretty simple. I doubt you'll be watching this video for this question, but yeah. B times 10 to the n is numbered 7,200, which is in standard form. Work out b times 10 to the minus n. So, alright, so we just have to work out what n is. Right, so 7,200 is equal to 7.2 times 10 to the, so 1, 2, 3, so, which is 1,000, so you can check it's pretty much correct. Look, right, 7 times 2, 10 to the 1,000, so you can see it's right. And then, so we want b times 10 to the minus n is equal to 7.2 times 10 to the minus 3, right? Goodness me, these are pretty simple. And so we get, so 7, 2, so we got the decimal point here, so we got 1, 2, and 3, so we got 2 zeros here on our point, so we get 0.0072. Right, be careful, it's not actually 0.00072, because the decimal point has still got to travel one more point here. Here is a number machine. Show that when the input increases by 2, the output increases by 2a. Right, I've seen this question before. I've had a couple people ask me about it, and actually it's not very well explained here. When it increases by 2, it literally means when the input goes plus 2, right? It's not multiplied by 2, not times. Right, so we've got the input x, and then so when we input x, we have x times a plus b equals y, which gives me that y equals ax plus b, right? And then obviously, so when we input x plus 2, so we get x plus 2 times a plus b is equal to 2xa. Right, let me write that differently. 2ax plus 2a. Very sorry, this is not at all right. So, which is ax plus 2a plus b, right, which is in turn equal to ax plus b plus 2a. We can see that this ax plus b is simply equal to y, so we substitute y into it when you have to y plus 2a, which is pretty much what you wanted to show, right? Yeah, so this is it. F of x equals kx squared, if k is constant. Carrie says f of 6 divided by f of 2 is equal to f of 3. Is he correct? Oh, sorry, Kai. Right, so we can literally just check. So let's see, f of 6 is going to be equal to k times 6 squared, which is 36. F of 2 is equal to 4k, which is 36k, which implies that f of 6 divided by f of 2 equal to 36k divided by 4k, which is, so the k's cancel out, remember, and 36 divided by 4 is equal to 9. And let's verify f of 3 is equal to 3 squared k, which is equal to 9k, which is not equal to 9, which is equal to f of 6 divided by f of 2. So Kai is wrong and should study more. Right, he definitely should be more careful with his maths homework. Right, is he correct? Right, I think in this case is also quite important. No, Kai is not correct. Right, this is still right, but I feel like it's very important to explicitly say no. Otherwise, you don't want them to give you any troubles or anything. So just give them what they want and then come up with your grade. Right. Here is a list of 11 whole numbers in numerical order. Lower quartile, median, upper quartile, and highest value are missing. And they give you a bunch of information about the quartiles. Right. So, right, how am I going to do this? Right, so you can literally input x. Because since all those depend on the quartile, on the lower quartile, we'll call let x equals lower quartile, right? And then we know that 2 times the lower quartile is equal to the median, so we got 2x here. Upper quartile is equal to 2 times lower quartile, 2.5, sorry, 2.5. Let me just write that, 5 over 2x. And the range is equal to 2 times the interquartile range. So the interquartile range is going to be, right, actually, let me come on to this. Right, so interquartile range is going to be equal to the upper quartile minus lower quartile, right, which is equal to 5 over 2 minus x, sorry, 5 over 2x minus x, which is equal to 3 over 2x, and which means that this value, so the maximum, is going to be equal to 3.2x, so the range, plus 5, right, so 5 plus 3 over 2x. So, right, so we know that this is equal to 3, right, 3 over 2x, right? So, I'd hesitated there for a moment, but this does seem to be correct, right? 2 times the interquartile range. Right, so, I'm sorry, no, right, okay, there's the mistake. It's actually 3x, because we want the 2 times the interquartile range. So, so inputs, range equals 2 times 3 over 2x, which is 3x. My bad. So this is going to be 3x. So 5 plus 3x, sorry. And now what we can do, we can pretty much have a look at possible values of x, since we are not given any more information, right? So we know there's 11 numbers. We don't know anything about the mean. We don't know anything else. So we just input values. So we can try 9. So we can try x equals 9, right? So x equals 9, which gives me 2x is 18, right? And then here we see we have our first problem, since we are given whole numbers, and we cannot have a half of a whole number of an odd number. So x equals 9 does not work. X equals 11 will not work, and equals 13, we cannot have that. So we are left with 10 and 12. And I do believe both of those values work. Right, I did actually have a look at the mark scheme for this question, since I found it a little bit weird. I believe both values 10 and 12 both work, right? I believe in the mark scheme they only give you either 10 or 12, and they don't say anything about the other. But if you check for 10, right, so this implies 2x, so x equals 10, x equals 12, 2x equals 20, which fits pretty well here in between 19 and 25. So this does work. And then, so 5 halves of 10 is equal to 25. Oh goodness me, right, so actually 10 does not work. So there we go. So they gave you 12. So 5 halves times 10 is equal to 25, which does not work. So hence we are here. So this can't work, right? This can't possibly work. So this the mark scheme was indeed full. So now we verify with x equals 12. So x equals 12, 2x equals 24, which indeed works here, right? It's just one lower than this. And then 5 halves of x. So half of 12 is 6, times by 5 is 30, which fits snugly in between 28 and 34. And then we can verify the last one, so it's 5 plus 3 times x, which is 41. So 5 plus 3x equals 5 plus 36, which equals 41, which indeed does work, right? So these values now are indeed going to be equal to. So let's fill them in properly. So this is going to be, we said 12. We said this one is going to be 24. This one is going to, goodness me, what else did we say? We said 41. Sorry about this, 41, and then right, and then this one was simply upper quartile was 2.5 times lower quartile. 2.5 times 12 is 30. Right, we did say 30. Right, perfect. 2.5, so 2 times 12 plus 6. That's fine. Right, so this answer is indeed 12, and we have shown why it cannot be 10, it cannot be 9 or 11. Once again, how important it is to read the question stating that these numbers must be whole. Right, ABCD is a trapezium. All four sides have different lengths. AB, so we have AB is parallel to CD, right? These diagonals, right? So plenty of opportunities here to test what you learned about angles. The diagonals intersect at X, right? We don't really care about that. Right, so for each statement, take the correct box. True, maybe true, not true. So I'm going to draw over them since I have a tablet and I can delete them afterwards, but I don't really recommend you doing that since it will get messy. AXB and CXD are similar, so AXB and DXC are similar, right? So we want them, so we know they're not necessarily congruent, as they say here. Similar just means that they look the same, pretty much. They have the same angles, the same lengths, the same positions, right? But it does not mean that they are the same size. And are they similar? Right. Well, let us verify that actually. So how to have them similar? So we need we can actually check the angles and check the sides. So the sides are actually not going to be the same, obviously here, since they are all of different lengths. So we can check the angles here. We have opposite angles. Well, yeah, they're called kind of angles. I think they're called, they are called vertically opposite angles. Sorry, I was just trying to remember the name. So you have different types of angles. You've got these ones which are vertically opposite. You got alternating angles, I think. Right, yeah, you got alternating angles, which is when you have these ones and these ones that are the same, and then you have the corresponding one, which is looks like the F, and you know this angle and this angle is the same, and you also know that this angle and this angle are the same, right? So these are important for angles. So let's have a look. AXB and CXD are similar, so we know that these are the same, so it's a good start. And we can, if we ignore these two lengths, we can see that this one and this one are going to be the same since they satisfy the condition for alternate angles, right? And likewise, these two are going to be the same since they also satisfy them. So we can see that this triangle has literally been squashed in and reduced in size and flipped, but these are indeed similar. Triangles AXD and BXC are congruent. Let me delete all of this. Are they congruent? Right, so AXD, so we want to check these ones, and BXC are congruent, right? So these have to be pretty much exactly the same. That's a fancy word for saying they're the same, right? So we all automatically know that that's not true, since we are given that all sides are of different lengths, and these sides must be the same, right, for them to be congruent, and this is clearly not true. These angles are also not going to be the same, since these sides must be parallel for them to be. So this could be true. However, we know that BC is never gonna equal to AD, right? So since triangle AXD has got AD in it, and triangle BXC has got BC in it, we know that those triangles are never or always going to have a side that is not equal. which makes it not true. Otherwise, if these sides could have been the same, we could have said that may have been true, but that's not true at all, since they will always have a side that is not going to be equal. So this is not true at all. This is actually a bit quite challenging to think of in an exam, right? I mean, once I've explained it that way, it seems pretty easy, but actually it's not that given, is it? Right. Next question. Angle ADB equals angle BDC. ADB, which is this one, BDC, which is this one, and we want to know if they are equal. Right, so how are they going to be equal? Well, the only way that these are going to be equal is if BD is a bisector, right? We want BD bisector. And the only way that this is going to be possible is if this is a parallelogram, right? So if AD and B and DC here are the same, and then we'll have BD proper bisector. However, once again, since all the sides are different lengths, these sides are never going to be the same, and this is never going to be a parallelogram. It's not going to be an anygram, to be fair. So this is once again not true. And finally, angle of area of ABC and area of ABD. Right. So area of, let me have a look at this. Area of ABC and ABD. ABC is going to be this one, and ABD is going to be this one. Right, so they're actually sharing two. Right, so let me actually properly draw them then. Properly. So we want to check these areas, and are they the same? Right, actually, an interesting property about triangles is between two parallel lines, two triangles that have the same base, so in this case AB, these are always going to have the same area. Right, why? This is actually quite important, and it's worth memorizing actually. Why do they have the same area? Well, we know that the formula for triangle is a half AB times height, right? A half base times height, which in this case gives us a half times AB times the height in this case, so where the base is AB. And if we look at this triangle right here, we can see that it shares the same base as this triangle right here, and this height here is going to be exactly equal to this height here, right? Since the height is the perpendicular, right? So let me draw that a bit better, because it's actually quite important here. The height of this triangle, so this kind of caves in a bit, is going to be this length here, and it's going to stop at DC, right? And the height of this triangle, let me draw in green to make it a bit easier to see here, is going to be in turn the exact same length here. Right, so we can literally see that they share AB, they share the same base, they share the same height, so these triangles are always going to have the same area, right? So there we go, same area, and we are done with this question. Right, question 16. Solve the simultaneous equations. Right, so we'll call them 1. So this is pretty standard once again, and 2, and so solve the simultaneous equations. So pretty much standard working out. A bit tougher, but no tricks, I think. Right, so a couple ways to solve them. What we are going to do this time is we're going to do 1 multiplied by we're going to times that by 3, which is going to give us 6x minus 15y is equal to 39, and we're going to times 2 by 2, and here this is going to give us 6x plus 8y equal to 16. Oops. Right, and what we can do is, so call this 3 and 4, and now what we're going to do is get rid of x to get y on its own, so we can either subtract one or the other. It doesn't really make a difference. I'm going to subtract 3 from 4, so 4 minus 3 is going to give so 0 plus 8y minus 15y. Be careful of the double negative y here. Is is 16 minus 39, which gives in turn, so 8y. So actually, let's skip this step. So we have 23y. It's going to be equal to 39 minus 16 is 23. So minus 23, which gives us in turn, I can't speak today, minus 1 as y, right? And this kind of looks more or less accurate, right? So I'd say it's a fairly good guess. So for question 16, yeah, I mean, yeah. So if we carry on, we get so now we need to find x. So we have 2x, so we just use the first equation, 2x minus 5 times minus 1 equals 13, which gives me 2x plus 5 is 13, which gives me, so 13 minus 5 is going to give me 8, and in turn x equals 4. So it's this simple, right? So let's actually give it to him. 4 minus 1 is this simple. One thing I'm going to note actually is be careful. It's more of a warning actually. Be careful with the double negatives. It's very simple, very easy to forget here that you got to subtract minus 15 and not 15y. Yeah, so the only way to really properly get around that is just be bloody careful and don't drop the marks. If you get a stupid value or decimal value, you can start and like, right, so you hang on, let me actually just verify this and properly, like, it's possible that they give you decimal values 100%, but like, just take a step back, have a look at it, check everything again, and then yeah, because it's not really worth throwing away those marks at the beginning when it's something that you can do, right? When it's something that you can't do, well then, there's nothing you can do about it. But like on these questions, it's a pity to throw in marks. Right, question 17. Solid hemisphere's radius x, solid cylinder's radius 3x and height x, right? So this is work out the ratio total surface area of hemisphere and total surface area of cylinder. Right, it's just a bit complicated. Well, for 3 marks, so it's quite simple, but just a little convoluted. Bear with me. What we'll do is break down the both shapes actually. So this one, so with the cylinder, so the surface area is going to be this rectangle bit that goes all around, and plus this area and the area underneath, right? So plus 2 times this circle thing. And for this one, you get the circle underneath and the hemisphere. Be careful, it's not actually a full sphere, but it's actually a hemisphere, so we'll have to divide by 2. So let's start with well, the first one actually, the total surface area of the hemisphere. So SA of hemisphere, so what's that equal to? So it's going to equal to, so 4 pi r squared. Right, let me actually directly substitute it in. So 4 pi x squared, since the radius is x, divide by 2. Since obviously we only have half a hemisphere, be careful with this because it's not actually 4 pi x squared, but divide by 2, plus pi x squared for the area of the circle underneath, which gives us 2 pi x squared plus pi x squared, which is 3 pi x squared. And right, so this is what we have. Well, that was quite simple. And now for the other, so what we're gonna have, so we already have this 3x, right? So we can easily work out the area of the circle. However, to work out this rectangle, we'll have to know the length, which is equal to the circumference, right? So it's going to be equal to this value around here. So how are we going to do this? Well, circumference of let's call it, let's rub this out and call it circle A. Well, actually, let's call it B since it's the same one. So this is going to be A. This is going to be B of circle B, just so you guys can keep up, can understand me a bit better. So circumference of circle B is equal to, so pi times diameter, which is equal to 2 pi r, right, which is equal to 2 pi times the radius, which is 3x, which is equal to 6 pi x. Let's call it 6 pi x, right? And then so we have this length, which is 6 pi x, so which gives me the surface area of what's it called, this cylinder. Yeah, cylinder is equal to, so it's going to be 6 pi x multiplied by x, right, plus 2 times the circle, 2 times pi r squared, where r is 3x, which gives us 6 pi x squared plus 9, so 18 pi x squared, which is 24 pi x squared. So we get a radius, so we get a ratio of 3 pi x squared to 24 pi x squared. So we can cancel these, which is equal to 128, right? Awesome. I hope you guys understood this. I mean, it's a bit convoluted, but yeah, it's just massive. Breaking down the problem into those different shapes and then solving it, it's not actually really difficult, is it? Let's say question 18, back to multiple choice. Circle the possible value of x with x between this, right? So we can rewrite this simply. I'll just show you one possible value, one possible method. So how would I do this? Right, so what's 6 cubed? So this means that 6 cubed is smaller than x, smaller than 7 cubed. Right, be careful. You can't always apply this technique of cubing or squaring everything when they are negatives. So be careful, right? So for example, if you have x's between -1 and -2, right? Square root of x. Well, actually, that's not possible, but just be careful, right? Right, so 6 cubed is equal to 6 times 6 is 36, times 6 is 180, plus 636 is 216, smaller than x, smaller than 7 times 7 is 49, so 50 times 7 is 250, minus 1 times 7 is 343. So we can really easily tell which value falls in here, and it's 290. Work out how many 5-digit odd numbers can be made using these digits once each. Do not list them. Right, this is actually starting to get a bit interesting, a bit more into what you're going to do A-levels. Right, so we want 5-digit odd numbers, and we have 5 digits. Right, so we can only use them once each. So it's pretty much combinations of all of these numbers, which are going to give us odd numbers, right? How do we have an odd number? It's a number that ends in an odd number, surprisingly enough. So it's either 7 or 9, right? Since all these are even, and we have only 2 odd numbers, right? So how will we get an odd number? It's gonna be of the form. It's 1, 2, 3, 4, 7, or 1, 2, 3, 4, 9. So odd. So these are the only odd numbers that we'll have that will satisfy these conditions. Now, right, so what we want to do, we want to effectively, let's consider this this case scenario, so of the 7 here. So effectively, we want to see how many possible ways we can mix these numbers into any numbers, right? We don't actually care what order they go into. So how many possible ways are there of mixing 4 possible numbers, right? So for example, as I said, it could be 2, 4, 6, 9, or it could also be 4, 6, 9, 2. We don't really care, since both these make an odd number. So how are we going about doing this? So let's look at the first position, right? How many possible numbers can we choose for it? Well, we can choose 4. Let's we have 4 possible options, so we're going to multiply by 4. And then second one, so since we've already picked one number, for example the 2, we only have 3 possible options left. So we're going to have 3 left, and here we're going to have 2 possible options left, and here we're going to have 1. Right, so this is going to give us, so 4 times 3 is 12, times 2 times 1, which is going to be 24. So we have 24 actual possibilities for odd numbers ending in 7. And here, likewise, it's exactly the same, except instead of having a 9, in here we have a 7. So for example, we could have 4, 6, 2, right? It could be literally anything. And so we have, once again, for this possible choice, we have 4 possible choices, and then since we've used the choice up, we have 3 possible choices for this one, and then 2 possible choices, and then for this one, there's only 1 choice, and we don't get to choose since there's only 1 number left, and that gives us 24 again. So we have 2 times 24, which is 48 possible odd numbers that can be made satisfying this criteria, and right, and this is it, and it's quite lucky that they do not ask us to list them. Right, K, L, and M are weights. Both of the scales balance exactly. K, 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 L, 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 K, L, M, M. Right. How many M weights are needed to balance 1 L weight? So this is pretty much rewritten as L equals how many M, right? Or equal to PM for P question mark. So we want to find this P. So we know that 3K equals 4L, right? And we know that K is equal to L plus 2M. And these scales balance exactly. So we know that this is correct. And we need M weights to balance 1 L weight. So what we can do, we can times this by 3, right? So we get 3K equals 4L, and we get 3K is equal to 3L plus 6M, and then we subtract them. So we have, let's actually do as we did before. So 1, 2, we've got 1, we got 2. So 1 minus 2 is going to equal to, it's going to give us, so 0 is equal to L minus 6M, and in this case L is equal to 6. Is equal to 6M, right? So in this case we have 6, right? So we need 6 M weights to balance 1 L weight, and let's actually verify it ourselves. So the L weights are actually smaller than the K weights, and then right, so this actually does make sense since all the weights are positive. We have an L weight which is smaller plus an MM weight. That actually does work out pretty well, and this, we can be pretty confident in our answer right here. Right, makes sense. Right, okay, next question. So question 21. Right, we have x squared minus 6x minus 15, and we want to express it in this form. So a little bit more challenging, but actually still really possible. So how do you go about doing this? Well, I like to actually see what's going on first. So for example, let a equals 2, right? So if we let a equals 2, then we would get from x minus a squared, we would get x minus 2 squared, right? Which would give us, in this case, x squared minus 4x plus 4. Right, so this is what we get in this case. So we want a 6 in this place of 4, right? So if we can really well see, if we try x minus 3 squared, we shall get x squared minus 6x plus 9, right? So now we have our x squared minus 6x here, and however we have a plus 9 here, and we actually want a minus 15. So technically, if we think about it, if we had x minus 3 squared minus 9 plus 15, which is indeed equal to 24, So this would be equal to x squared minus 6x plus 9 minus 24, which gives us indeed x squared minus 6x minus 15, right? So the answer is actually x minus 3 squared minus 24. Right, so pretty much we need those two numbers. We need 2a to add up to 6, and then we make up the difference with b. A equals root 2 and b equals root 18. So a couple thirds. Right, I think we can start off by simplifying root 18, which is equal to 2 times 9, right? 18 is 2 times 9, and we know that 9 is 3 squared, so we got 3 root 2. So this is pretty much just to see if you've revised your surds, right? So you can multiply surds together. So remember, root B is equal root AB, and then you can actually take them out like I just did here. And yeah, that's just pretty much all you can do. So root A squared, which you can see is 2. So A plus B is equal to, so root A plus root B. So A plus B is equal to, let's just write it here. So we have root 2 plus 3 root 2 equal to 4 root 2, right? So we got 3 root 2, we got 4 root 2, and it's right here. AB, so AB is equal to root 2 times root 18, which is equal to, since I just simplified it, root 2 times 3 root 2, which is equal to 3 times 2, which is 6. So AB we know is 6. B over A, so it's root 18 over root 2. We can just simply divide, which gives us which gives us 18 divided by 2, root 9, which is either plus or minus 3. However, in this case, they don't really seem to care about the minus 3, so we have B over A is 3. This simple. It's quite a nice question 22, to be fair. It's probably just as a breather before we get into this. Right, 0.13 recurring as a fraction in its simplest form. Right, I remember doing these when I was doing my GCSEs. Never could get the hang of them. But I'm going to give you guys a pretty easy method to do. So the way to think about those is, so 0.13 recurring, right, is actually equal to 0.1, right, plus 0.03 recurring, right, or it's also equal to 0.13 plus 0.003 recurring, right? So this is just to give you the trick. So how does it work? So we're not actually going to bother with this. So we're going to use this, right? So we know that 0.1 is equal to 1/10. And now the challenge is to find what 0.03 recurring is in terms of fraction. Right, so 0.003. So we can literally just check. We know that let me actually write it properly. We know that 0.3 recurring is actually a third, right? Of course, we know that before. So 0.03, so 0.3 recurring. So what's that going to be? So it's actually a third divided by 10, right? It's a third with an extra 0 here. So a third divided by 10 is a third times 1/10, which is equal to 1 over 30. So therefore we get 0.13 recurring is equal to 1/10 plus 1 over 30, which is 3/30 plus 1 over 30, which is equal to 4 over 30, or 2/15, right? And if we use a calculator, so 2 divided by 15, and verify that it indeed gives us 0.13 recurring. So we know that this is 2/15, right? So the trick is literally actually to verify, to pretty much split it up, right? Split it up, and then you'll have easier numbers to work with. Make sure to remember that, actually, because these do come up quite often. Right, question 24. We've got a few left, only a few questions left, so let's try and finish it properly. Question 24. Points P, Q, and R 8 to 22 form a triangle. P is a horizontal line with P PQ is horizontal, right? Y-axis, right? So we want to find these coordinates, and it looks like we're gonna have to find these ones, and then use from these ones, and then afterwards we'll be able to find these ones, right? So let's start. So let's give let 0 y be the coordinates of P, right? Let x y be the coordinates of Q, and we want to find what right, let's actually write it properly. Want to find xy, right? So gradient of P is 2. Actually, there's a bit of space, right? Okay, so might need a bit more space. I'll delete some of my writing if I need the space. Right, so we have our R here, and PQ is horizontal line. So we know that R has got is at the point 822 with a gradient of 2. So that means that if you remember your dy by dx, your changing y by changing x is equal to the gradient. So you know that the change in y, so grad of PR is equal to, so what's the change in y divided by change in x? It's actually equal to change in y is equal to 22 minus y, right? And change in x is equal to 8 minus 0. Right, so this is what we have, and we know that this is equal to 2, so we can actually solve for y now. We have 22 minus y is equal to 16, which gives us that y is equal to 6. So we know that this is 0.06, and right, so now we can find q. So remember that from class that when you have a 2 lines of perpendicular gradients, right, so their gradients are actually related in that their gradients are the inverse reciprocal, right? So the gradient of this line is going to be minus 1 over 2, just like this one is going to be minus 1 over 2, which is going to give you 2. So we know gradient of RQ is equal to minus 1 over 2, and we literally just repeat the exact same stuff. So we have so we go from point R, so we have change in y is equal to 6 minus 22 divided by change in x, which is x minus 8. Is that right? Yeah, x minus 8 is equal to minus 16 over x minus 8 minus a half, which gives us 16 over x minus 8 equals a half. And then so we can pretty much solve. In this case, we have 32 is equal to x minus 8, and we have that x is equal to this certain point called 40. So this was question 24, right? So I hope you guys understand. So literally there's tricks, you just have to know pretty much what you learned in class, right? That the gradients are negative reciprocals, and yeah, changes in x, changes in y. These questions are not actually difficult. They just require you to properly know what you're going on about, right? So it just comes with practice. Like, as long as you know your stuff, you just pretty much have to practice and do past papers. Right, so we have 40 and 6, and we are good. Gucci, right. Show that 4 sine 30 minus, right, this is actually another quite simple one. As I just said, literally proving my point, you guys need to know what your values are, right? So there's a table. I can write them down for you. I'll only do a certain number. So 30 degrees, 45 degrees, 60 degrees for sine, cos, tan, right? And I've actually, when I used to learn this, I stumbled upon the video of a great Indian gentleman who, with a strong accent, taught me this song. I won't sing it for you, but how did it go? It went 1, 2, 3, 3, 2, 1. Right, 2 under everybody, and square root where has no one. Right, I'll stop with the Indian accent, but this gentleman really helped me, honestly. Thanks to him, like, I actually managed to remember those. So you have root 2, and then so you got root 3 over 3, over 3, 1 root 3. So this is pretty much, you got to learn them, right? And then afterwards you have the 90s and the 0, which are actually pretty simple, which I won't do today. But once again, you have to learn them whichever way you want to learn them. It doesn't matter, but just learn them. It's this simple. You won't be able to, well, you could, but it will require a great deal more effort to find them out in class. Right, so full sine 30. So let's call this formula star, so which implies star is equal to 4 times a half minus tan 45, which is 1 divided by 2 cos 30. So cos 30 is 2 root 3 over 2, which is equal to 2 minus 1 over root 3, which is equal to 1 over root 3. And right, now you might say, oh right, there's not actually any 1 over root 3 here, but remember, 1 over root 3 you can just times by root 3 over root 3, which gives you root 3 over 3, and which is indeed tan 30. So, and we can verify x is indeed, well, 30 is indeed acute, so we have our answer. It's this simple, guys. This simple. Question 26, and I believe this is the penultimate question. It is. So let's get on with it. Circle center O has circumference 20 pi centimeters. Q is a point on the circle. OPQR is a square. Perimeter of the square. Right. So it's pretty much like the other question we did. We need to find A this time. So let me just verify. Right, so we have 20 pi here. We have Q, a random point. We don't care about this, and we know that this is a square indeed. Well, we know that, right? We can see that. Perimeter of the square. So let's actually, well, let's start with 1 and 2. So we can start with, let's start with the more complex one this time. The perimeter of the square. Right, you can tell that I've not been. Perimeter, right. How would this work? So we need to know this A, we know this is A, this is A, this is A. And we know that this, we can work out the radius. So we know the circumference is 20 pi. So circ equals, so pi times diameter, which equals 2 pi r, which is equal to 20 pi this time, which gives us that r is actually 10. So we know that this r is equal to 10, and we can use Pythagoras to work out A now. So we know from Pythagoras, or Pythagoreus as the Americans like to call it, we pretty much can work that out, that a squared plus a squared equals 10 squared, which gives us that 2a squared equals 100, which gives us a squared equals 50. Right, which in turn a is equal to plus or minus root 50. It can only be positive, so plus square root of 50. If you know your surds, you know that this is 225, 5 root 2. So we know that a is equal to 5 root 2, which implies square perimeter, let's just call it perim, is equal to 4 times 5 root 2, which is 20 root 2. So this is our square perimeter. And now we want the circumference of the circle. So, well, you already know that actually. I didn't actually notice that. Well, so, which gives us that the ratio, I won't bother writing it out, is equal to 20 root 2 to 20 pi, which is the same as root 2 to pi. And we can see that our a is equals a, right? Yeah, very interesting. Right, a equals 2. Let me actually properly write it. Awesome. So we find a equals 2. Very simple. Quite a nice question actually. Nice and square. Once you get to A level and university level maths, if you do decide to pursue such a career, it gets much different. I seriously recommend you researching about the contents that you will be learning if you do decide to study that. It's much different. A journey has 2 stages, right? Last question. Show that the average speed for the whole journey in kilometers an hour is, right, so average speed. So we know speed is distance divided by time. Although actually they give us all 3 of them, so we won't need this this formula today. We have average speed. We want to show that 2ab plus right, so well, we can actually literally just calculate it from there, to be fair. So speed is distance for our time. We might actually need this equation finally. So which is distance is 60 divided by our total time, which is 30 over a plus 30 over b, which is in turn equal to, right, so how can we solve this? Well, we can just rewrite this actually as 30 b over ab plus 30 a over ab. So if you guys are wondering what I did here, I literally just multiplied, well, actually let me write it here. So 30 over a is equal to 30 times b over b, which gives 30b over ab, and likewise with this. And this allows me to simply create a common denominator, 60 divided by 30b plus 30a, oops, right, over ab, and then pretty much we can, so this is in brackets, and we can pretty much, so multiply by ab over ab, so this one cancels out, and we are left with 60 ab over 30b plus, oops, this should be a 30a, right, and this gives us in turn, so we can cancel b, we can cancel, actually we cannot cancel b, sorry, that is a stupid thing to do. We can simply divide by 30, which gives us 2ab over b plus a, which is actually pretty much the same as 2ab over a plus b. Right, well, that was quite a nice paper actually. It was not very difficult, especially for a non-calculator. These did used to be my favorite types of papers, since they did not require such illicit calculations. Like they remain simple, right? And I love GCSE maths. Found it very, very interesting, and I hope that you guys understood most of my explanations. And I do tend to go on tangents, but yeah. So I hope you guys have understood this. I'll try and keep the video not too long, so I'll end it now. Thank you very much for watching, and let me know if you have any questions or anything, and I shall try and help you. Cheers guys, thank you.